Everybody, I'm Hung from Piyang location, and now I will talk about a very interesting topic. It is the mysterious origins of life on Earth. So, billions of years ago, on the young planet Earth, there's a simple organic compound assembled into more complex collisions that could grow and reproduce. They were the very first life on Earth, and they gave rise to every uh, species uh, species that we have discovered on Earth. So, so the young planet Earth on that time had a widespread volcanic activity and an atmosphere that created hostile conditions. So, where Earth could life begin? So, to begin for the to begin to shut for the cradle of life, first we need to understand the basic necessities for any life form. So, elements and compounds essentials to life include hydrogen, methane, nitrogen, carbon dioxide, phosphates, and ammonia. So, for these ingredients to commingle and react, they need a liquid solvent that is water. So, in order to grow and reproduce, all life need a source of energy. So, the life form divided into two camps. First, autotroph, it like plant, it can generate their own energy, and heterotroph, like animals that consume other organisms for energy. So the first life form wouldn't have had some organism for them to consume. So of course the first life form actually is uh was autotroph. So so what location meet the criteria? Places on land or close to the ocean have the advantage of access to the sunlight, but when the time life began, the UV radiation on Earth's surface was likely too harsh for life to survive there. So one setting offered protection from this radiation and an alternative energy source. It is the hydrothermal vent. So, what is a hydrothermal vent? It is a fissure on Earth's crust where the seawater seeps into magma chamber and is ejected back out at high temperature along from the rich uh, rich slurry of minerals and the simple chemical compounds. So energy is particularly concentrated at the steep chemical gradients of hydrothermal vent. So there's also another line of evidence that point to hydrothermal vent. It is the last universal common ancestor of life, or LUCA for short. So Luca is wasn't the first life form, but it's as far back as we can trace. So we don't actually know what Luca looked like. There's no Luca fossils and no modern Luca still around. So instead the scientists identified the genes that is commonly found in species or three domains of life that exist today. Since the since these genes are shared across species and domains, they must have been inherited from a common ancestor. So these genes tell us that the Luca live in a hot, oxygen-free place and harvested energy from a chemical gradient like the ones at hydrothermal vents. So, there's two kinds of hydrothermal vent. It is black smokers and white smokers. So the black smokers release acidic, carbon dioxide rich water, and it can reach to hundreds of degrees Celsius and packed with sulfur, iron, copper, and other metals essentials to life. But the scientists now believe that the black smokers was too hot for Luca, so now the top candidates for the cradle of life are white smokers. So, there is a field of hydrothermal vents on the mid-Atlantic ridge called Lost City has become the most favored candidate for the cradle of life. Like the seawater expelled here is highly alkaline and and lacks carbon dioxide, but it is rich in methane and offer more hospitable hospitable temperature. So this evidence giving it all the components to the support for the first organism that radiated into the incredible diversity of life on the earth today. So this is the end of my presentation, my moral summary. Thank you for your listening.